From the word chance, a letter is chosen at random. What is the chance? What is the probability, or what is the chance that the letter is an A? Obviously, that is just 1 out of 1, 2, 3, 4, 5, 6. What's the probability to C? 1, 2 out of 6. A vowel, 1, 2, 2 vowels. Consonant, obviously that should be 4, 1, 2, 3, 4. That's not a vowel. And not a consonant, well, if it's not a consonant, then that would be it's a vowel, right? So 2 out of 6. Again, you could have simplified all these, 1/3, 1/3, 2/3, it doesn't matter. Any questions? Easy. 2 dice are rolled and their sum is calculated. The results are to be listed in the table. Complete the table. 1 plus 4, 5, 6, 7. I'm sure we should have been able to complete this. See, that was easy. 2 marks for completing the table. 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. Which is the most likely sum? Obviously, it's 7, right? Because 7 occurs the most. What is the probability that the sum will be odd? Well, where's your odd numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 odd numbers. Out of how many numbers are there altogether? 36. So 18 out of 36, which is obviously a half. So you could have done it 2 ways, just known it or half. I'll write 18 out of 36 here. Less than 7. Well, less than 7 would, does that mean you include 7? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36. A square number, well, we know what that is now. We know that's 1, 4, 9, and then obviously there isn't 16. So that's 1, 2, 3, 4, 5, 6, 7. 7 out of 36. A prime number. Prime numbers don't have any composites, right? So 2 is a prime, 3 is a prime, 5 is a prime, 7's a prime, and 9 isn't, 8 isn't, 10 isn't, 11's a prime. So what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 36. Easy so far. Divisible by 3. What's a number that's divisible by 3? Well, that's 3, 6, 9, and of course 12. So how many do we have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 36. A multiple of 4. So you can see it's not that this question is not hard, it's just long. Multiple of 4. A multiple of 4 would be 4, 8, and then of course 12. So what's that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 36, and then a factor of 12. Well, a factor of 12 will only be 12 itself. Is 1 a factor of 12? Yes, but it's not here actually, so no, forget it. Factor of 12 is just 12, so 1. 1 out of 36. Any questions about any of those ones that we just did? Okay, number 3. A bag contains numbered balls. The probability of selecting a 2 was half. A 3 was a third. The remainder of the balls were numbered 1. So what's the remainder? What's a half plus a third? That would be 5 out of 6. So half and a third is already 5 out of 6. So the remainder of the balls were numbered 1. That means 1 occurred 1/6 of the time. Does that make sense? Does that make sense? So pretty much if you guys want to check it, a half plus a third plus 1 out of 6 needs to give you the total probability, which is always 1. You can't go higher than 1, right? Or 100%. So that's what I've done there. So half plus a third is 5/6, and I subtract it by 1 to get 1 out of 6. That's a tricky one. What is the smallest possible number of balls in the bag? All right. What's the smallest number of... Can you have like 5? Well, no, because you can't get half of them being 2. The only way you would work out what's the smallest number was to find this addition, which was 5 out of 6. Then you realize the number 1 occurred 1 out of 6 times. So what's the smallest number of balls that could have been in the bag? It would actually be 6. Tricky. That one's tricky. I'm not going to say who actually got that one out. Did anyone? No, girls, no. Anyone at home able to see that one? No? Nobody? Yeah, that's a hard one. So we realize, okay, we need some more of those styles of questions. I get it. So what is a small, do we get what I've just done now? So you guys can see 2 occurred half the time, which means there was 3 2s, right? Because 3 out of 6 is a half. 3 occurred 1/3, so there's 2 3s. 2 out of 6 is a third. And then there's obviously 1 out of 6 here. It's very important that you guys understand how I got this 1/6. Again, do we understand how I got this 1 out of 6? Anyone not understand how I got the 1 out of 6? Yes? Don't get it?
Yeah, I have the 6.
Yep. So again, the probability of selecting a 2 was a half. So imagine you've got a bag and you've got a whole bunch of 2s and then you've got a whole bunch of 3s and you've got a whole bunch of 1s. Right? Now, you're not sure exactly how many greens, blacks or reds you've got, or how many 2s, 3s or 1s you have. But what you know is this occurred half of the time. You know this occurred a third of the time, and then whatever's remaining, the remainder is whatever's in red. So like the number 1. So hold on. So now in total, what's the probability in a bag? In total, what's the maximum probability that I can have?
Whoa.
12. Oh no, you're counting the dots maybe. No, I'm talking about total probability. Just forget the dots. Maximum probability. What's the maximum probability ever allowed? Say that again? 100%, yeah? Or the number 1, right? If you're dealing with decimals. So 100% if you're dealing with percentages, otherwise it's the number 1. So if you already know half of them are like green, 1/3 of them are black, and then you've got the remainder, and you know your maximum is 1. So isn't the remainder going to be 1 minus half plus a third, whatever these two are? Does that make sense?
Oh yeah,
Are you sure?
pretty sure.
Again, I'll do it in an easier way now. Let's say, let's say I gave you this is a half. Let's say I gave you this was a third. How would you work out this remaining bit? Well, again, you guys know this whole thing adds up to one whole pizza or one whole pie or one whole whatever it is, right? So to work out whatever's left, to work out this bit, you would say 1 minus, you've already eaten half, that's gone, and you've eaten a third, minus a third. And that also gives you 1 out of 6.
Oh, that makes sense now.
That makes more sense, right?
Yeah.
Yeah. All right then, maybe more visual like that, pie charts. There you go, we got there. And then once you know the denominator is 6, it's saying what's the smallest possible number of balls in the bag? The smallest would be 6. So there's 6 balls altogether. What is the probability of selecting a 1? Well, we just worked that out. That's 1 out of 6 times. A number less than 3, does that mean you include 3? No. So less than 3 would be a 2 and a 1. How many 2s are there? We said there are 3 2s. So 3 plus 1. 3 plus 1 is 4. So 4 out of 6 is 2/3. An odd number would be a 1 or a 3. Well, there's 2 3s and then there's 1. So 2 plus 1 is 3. 3 out of 6 is a half. Well, of course, even number is a half. So an odd number is also going to be a half. I should have just known that. That doesn't matter. That was tricky. I'm not going to say that was easy. That was a difficult one. I can't see many students getting that right, except for those who actually understood it the way maybe I did it up here. This little pie chart, because that probably makes the most sense. All right, let's try question 4. Question 4, I die. How come I can't? Oh, just. Question 4. A die has been renumbered with the number 3 replaced with the number 2. So that means instead of it, question 4, instead of it being 1, 2, 3, 4, 5, 6, the number 3 is replaced with the number 2. So that's not there anymore. It's a 2 now. If the die is rolled, what is the probability that it is a 2? Well, again, how many 2s do you have? You now have 2 2s out of 6 numbers. What's the probability it's even? 1, 2, 3, 4. 4 out of 6. What's the probability that is less than the 3? Well, that's 1, 2, 3. Half. 3 out of 6. See how question 4 was a lot easier than question 3? That's what I was trying to say with in exams. It's good for you guys to start getting used to skipping. If a question is really difficult, within a minute, within 10 seconds, actually, 10 seconds, you've got to train yourself to move on. I've got year 12 students that still can't do that. They still ponder on questions for maybe 3, 4 minutes, 5 minutes, 10 minutes on the one question that they might get right or they might get wrong. And then what they've done, they've sacrificed the rest of the paper for just this one concept, this question 3, let's say. Be careful, because for example, we just saw question 4 was a lot easier than question 3 was. So you could have bagged 3 marks, but if you had tried to focus on just question 3, you might have lost not only question 3 mark, but you would have also lost question 4, question 5. And that's when you guys come back and say, Sam, I couldn't complete the paper. It's because you were pondering too much on the one question. Question 5. Let's try this one. A colored ball is randomly chosen from a bag. The table shows the probabilities of the 4 colors. Again, what's the probability of all of these meant to add up to? What are they meant to add up to?
100.
100% or 1. Again, if you're dealing with decimals. If you're dealing with percentages, this would be 25%, 30%, 10%. You know, that's 55, 65. So then this would be 0.35 or 35%. So what is the probability of selecting a red ball? Probability is 0.35, or you could have said 35%, or you could have simplified it as a fraction, which is 7/20. See how many different answers there are? Doesn't really matter, they're all the same. Cool. Part B. If there were 40 balls in the bag, how many balls of each color are there? If there were 40 altogether, if there were 40 balls altogether, we know 25% are blue, so blue, green, let's just do it here. If there was 40 of them, 25% of 40, 30% of green, 35% red, and then 10% are yellow. So what's the answers we're looking for? For yellow, it's 4. For green, it would be 12. For blue, it would be 10. What's that? 32. No, sorry, 22. 22 plus 4 is 26. I'm guessing 35% of 40 is 16. Can someone double check that? 35. 14. Yep, Sam can't add. 14. Thank you. 14%. 14 of them. That was easy, wasn't it? Just multiplying. Again, you guys can see that was a lot easier than probably question 3. Explain why there cannot be 10 balls in the bag. Because, I mean, if you had 25% of 10, that would be 2.5. You can't have half a ball. So, you can't have half. What is the smallest possible number of balls in the bag? Okay, again, that question. What is the smallest possible number of balls in the bag? Oh, I've worked it out here for you guys. So the smallest number, 30%. Can you do 30% of 20? I don't think it shouldn't work. 30% of 20. Oh, it does work out. Done. All right. It's already here. Your denominator is 20. So the least you're going to have is 20. 25% of 20, 30% of 20 works, 35% of 20, and then of course 10% of 20. Wait, 35% of 20? No, that doesn't make sense. 35% of 20. I know it works, 7. I'm not wrong. I don't know what I'm confusing myself. That one's a hard one. I think we've got to continue these smallest possible numbers next week. I didn't realize it was going to take us that long. All right, all good. Not bad. I think just those harder ones. Maybe we'll look at really hard probability next week, and then we'll start on data. I'll stop that.